Good afternoon, everyone, and welcome you all for today's class. Yesterday, we have discussed about streamlines and stream tubes. We have derived streamline equation, and this streamline equation is useful for deriving stream function. And today, we are going to discuss what is stream function and what is its physical significance in flow field. So let us start what is stream function, and this is a hypothetical mathematical function, but it justify flow field. It is though it is a imaginary mathematical function, but it is fit in defining any flow problem that is involving streamlines and rotational or irrotational flow, whether velocity potential exists or not. All these things are related each other, and so this is very important from comparison point of view, from your subject point of view, from competitive examination point of view, particularly in public sector. So that's why just I feel we discuss what is stream function. So it is a mathematical function, stream function. It is defined by notation psi. Stream function psi. It is a mathematical function defined in such a way that for a flow field, partial derivative del psi over del x equal to minus v means velocity in y direction. Partial differentiation of the stream function psi about x-axis denote the velocity along y direction. Velocity along y. If it is x and this is y, so this is the velocity along y direction. If it is velocity along the x direction, and this is in one direction, you have to take a negative sign. It is just defined in mathematics. There is no any proof that why we are taking negative sign. But if you take negative sign for this one, then you take del psi over del y will be positive. That is a u. So this is a stream function, and psi is a function of xy. Psi is a function of xy. Only psi is a function of xy. So this is a statement of the stream function. It is a mathematical postulate, you can say mathematical function psi in such a way in flow field that partial derivative along x direction gives velocity along y direction, and partial derivative of this function about y direction gives velocity along the x direction. So this is fit for the flow field. So now it is a function of xy. So total derivative of the psi is a function of xy. We take total derivative d psi. D psi can be written as a del psi over del x dx plus del psi over del y dy. This is a general equation related to the stream function, and already we have defined that del psi over del x equal to minus v dx and plus del psi over del y is a velocity along x direction, so dy. And recall from our streamline equation denote that dx over u equal to dy over v equal to dz over w. But for two-dimensional x, y, if flow is a planar in two dimension, x and y, you can say dx over u equal to dy over v. So dy by dx equal to v by u. Simply you can say u dy minus v dx equal to 0 from streamline equation. So putting this value equal to 0, d psi become 0. This means that psi equal to constant. This means that for any streamline, stream functions remains constant. For any streamline, stream function remains constant. There are so many streamlines in a flow field, but for each streamline, this function remains constant. So we can define it, we can show it on a flow field. So let us define how it means. So this is a streamline. These are so many streamlines, and for these streamlines denoted by different stream functions. These are constant, psi 1, psi 2, psi 3 and psi 4. These are different streamlines for streamline 1, 2, 3. these stream functions remains constant for each streamline. This is a significance of the stream function. Means this one psi1 is different from psi2, psi2 different from psi3, psi3 different from psi4. So what is the physical significance of these streamlines? What these streamlines denote in physically? How we define what is meaning of what is between these two streamlines? That I want to define here. What is flowing between two streamlines? What difference between two streamlines denote? That I want to here justify. So let us define here. Let us take two streamlines. Instead of so many, we take two streamlines. Two streamlines. These are two streamlines. These are two streamlines. This is a psi and a psi plus d psi, and this one is a psi. There are two streamlines and flow between these two streamlines. And suppose the velocity at this point is v. V is a net velocity, and you can this distance. This is m n, and this is O, M and O, and this is dx, and this one is On equal to dy. We are taking direction x and y. So V is a total velocity. It can be resolved into two components. This is a total velocity V. We can resolve two components V and U. V and U. V and U. So what is total? What is total flow per unit thickness? Because here two dimensional. So we can define what is a flow. What is flow per unit thickness? How much fluid is flowing per unit thickness? So here, suppose this is a flow. V is velocity. So V into this is df distance. This distance is ds. Mn equal to ds and mo equal to dx and n equal to dy. So v into ds. V into ds means flow across mn. Flow across mn. Flow across mn per unit thickness. Because in this direction we are taking thickness unit, and in this direction v into ds equal to area meter square per second. So v into ds equal to flow across MO and flow across MN. That is a V is a negative because it is downward. We have taken direction like this, X and Y. Anything below will be taken negative. Anything this side taken negative. Anything this side taken positive. Anything this side taken positive. So V due to V, it will go down, means flow occurring across MO due to velocity V, and flow occurring across ON, which is due to U. That is equal to minus V into dx plus U into dy. So V into ds equal to minus V into dx and plus U into dy. Putting value of v and u again, that is equal to del psi over del x dx plus del psi over del y dy. Again from the using velocity u and v, putting in terms of the psi. So this is equal to d psi. This is equal to d psi. Already we have defined d psi equal to del psi over del x dx. So here equating equation number, this one equal to this one because these are same. So vds equal to d psi. That is equal to meter square per second. So what is the physical significance of flow? What is physical significance of two streamlines? Psi plus d psi and psi. This one is a psi and this is denoted by psi plus d psi. So d psi means the difference of two streamlines denote flow between these two streamlines per unit thickness, means meter square per second. So d psi difference of streamlines between two streamlines, d psi denote the flow, means vds equal to dq. Flow between two streamlines means per unit thickness. That is a physical significance of this psi, means psi denote flow between two streamlines. Flow because just like acting like a steam tube, between two streamlines it is just some flow is occurring. So flow will be defined meter square per second because thickness we are taking unit. That's why meter square per second. So let us take example so that this concept will be very clear for you. And let us solve one question. basis to justify what is the physical significance of psi and between two streamline d psi. So let us now start question. This is the question, a stream function. So this is a question, a stream function is given by equation psi equal to 4x square y plus 2 plus t in bracket and y square. Find the flow rates across the faces of the prism, faces of the triangular prism OMN having thickness 5 meter in z direction at the time t equal to 2 seconds. This is the question where we have to find out what is flow rate across OM, across ON and across MN. And thickness here is given 5 meter. This thickness along the perpendicular to this board. This is thickness. This is prismatic type of the some flow channel through which flow is occurring. And equation of the stream function is given. So let us solve this one. Again drawing this O 0 0 and this one is a N and this is a M and this length is given 2 meter and this length is given 3 meter. This length is given 3 meter. So first of all we have to find out coordinates of O, M, N. So this is 0 0, it is clear, and coordinate of this one is equal to 2 and 0 and this one is a 0 and 3. These are coordinates. So let us find out the value of stream function at these points. So psi at O equal to, what is psi at O? Stream function at O, because your coordinates are x and y are 0 0. So putting equation is given psi is given 4xy and plus 2t plus 2 plus t y square. This is equation is given. So putting at 0 0 means x 0 y 0. So equation will be 0. Psi at O means at origin psi value of stream function is 0 at point M. Now psi at M equal to, here coordinates are 2 and 0. So again 0 plus this will be again 0 because y is 0. So it is again 0 equal to 0. Now finding value psi n. Here x equal to 0 and y equal to 3. So first term becomes 0 and second term will be 2 plus at t equal to 2 seconds. Given t equal to 2 seconds. So 2 into 2 square, so equal to 16. So psi n equal to 16. Psi n equal to 16. Now finding out flow across OM. Flow across OM. That is equal to OM. That is equal to 5 because thickness is given. So we have to multiply with thickness. 5 into psi m minus psi O. So 5 into, already we have 0 minus 0 equal to 0. Now finding flow across ON. Flow across ON equal to ON equal to 5 multiplied by psi n minus psi O. That is equal to 5 into 16 minus 0 equal to 80 meter cube per second. 80 meter cube per second. Similarly, you can find out psi flow across NM. That will be same value that we have calculated for the flow across ON, because already across this one is a 0 and across this one is a 80 meter cube. So that flow will be same. This flow will be same occurring like this, because in this side there is no flow and in this side there is a 80 meter cube per second. So flow across MN will be same, that is flow across ON. You can simply find out across QNM equal to 5 psi n minus psi m. That is equal to 5 psi n equal to 16 minus psi m equal to 0. That is equal to 80 meter cube per second. 80 meter cube per second. So this is a way you can apply, you can interpret physical significance of the stream function in solving flow across streamlines. So between two streamlines, it is a flow occurring between two streamlines meter square per second, because we are taking unit thickness. If you multiply it by 1 meter, then it becomes meter cube per second. If you take thickness 1 and multiply it then meter cube per second it will become, but per unit we are calculating for area, so it will become meter square. Here thickness was given 5 meters, that's why we multiplied by 5 meters, so it become 80 meter cube per second, not 80 meter square per second. 80 meter square per second when we take only area, not thickness. When thickness is given, then it will become psi into thickness, then it is a flow rate Q across ON, OM and NM. So this is a very small discussion and very significant discussion. What is a psi and physical significance? Then we will discuss in next lecture what is a phi velocity potential. Just it is it is just opposite concept, because we have taken partial derivative along x direction equal to velocity along y direction, but stream velocity potential is defined flow field in such a way that partial derivative of the velocity potential along f direction will give velocity along f direction, that is equal to u, and partial derivative of the velocity potential along y direction give velocity along the y direction, that is equal to v, and we will not take any negative sign because this is just, that's why stream function and velocity potential cut at 90 degree. These are very useful concept how stream function is related to velocity potential. So we will discuss in next lecture. I think this is very interesting discussion, and it is always you will find one question from this topic, stream function. How we can calculate from stream function to velocity potential, and from velocity potential to stream function. These can be calculated because both are interrelated. So thank you very much for watching my video lecture, and please like and subscribe and share it to your friends, and have a nice day. Thank you.